Sorry, folks, there we go. Thanks, Jess, and thank you for inviting me to this symposium, and I'll try and get us back on time. I'm calling in from the banks of the Brisbane River, and that's the lands of the Turrbal and the Yuggera people, and I'd like to acknowledge their continuing connection to these biodiverse lands now and into the future. Today I'll be talking about some spiders that are very close to my heart: pelican spiders, or assassin spiders, archaeids, which Mel already mentioned due to their occurrence in the Stirling Range in Western Australia. I'm going to try and link some of my expertise, which is more in systematics, with conservation biology, given that these spiders are quite significant in the conservation space and were certainly heavily impacted by the 2019-20 fires. This is highly collaborative work with myself and colleagues here at the Queensland Museum and the Queensland Parks and Wildlife Service. So as we know, the 2019-20 summer fires were enormously extensive, significant and devastating in scope. Millions of hectares of natural habitat were burnt. And here in southeast Queensland, really large areas of fire-sensitive rainforest was affected, and including areas in the Gondwanan World Heritage Area and some of our most significant rainforest habitats. So full impact assessments that have sort of followed on from those fires have understandably largely focused on vertebrates. And of course, that's why we're here, right? We're trying to get a deeper understanding of what's happened to some of the invertebrate lineages following these fires. And at least in southeast Queensland, taxa like the tiger quoll and frogs and other things have been a real focus of sort of post-fire assessment studies. But invertebrates have also played a role, and so I was really interested in what the impacts of these fires were on fire-sensitive rainforest invertebrates, in particular those that are dispersal limited. So the sorts of things that Mel was talking about: short-range endemic invertebrates, particularly very small things, and how can we measure those potential impacts, given often how little we know about these animals. On the right there is a photo of the Main Range National Park, which is part of our World Heritage estate here in southeast Queensland. That used to be complex notaphyll vine forest, and that's what it looked like this year after the fires. So really the question is, what happens to these sorts of invertebrates when that sort of event happens? To answer some of these questions, the Department of Environment and Science here in Queensland Threatened Species Program received part of the Phase 1 bushfire funding that I suspect many of us who are talking today will have tapped into. That included an invertebrate component, fortunately. And so that was a collaboration that DES had with us here at the Queensland Museum. And that's where we tried to use our expertise, our museum collection data, new survey data and spatial analysis to try and understand the impacts on some of these animals. And I'd like to really shout out to Tracy Churchill and Mel Laidlaw from Threatened Species Operations for incorporating invertebrates and collaborating with us in this work. So I'm going to be talking about pelican spiders, archaeids. They're marvelous animals. They're certainly among my favourite spiders. They're called pelican spiders, as I hope will be for obvious reasons. They've got these remarkably elevated cephalothorax, head regions, and these spiders are amazing because they were actually known from fossils before they were found alive in the forests of Madagascar. We're very lucky to have them in Australia. They're actually a Pangean group, very rich fossil record, and these things are niche conserved, so they're restricted in their ecology and their habitat, and they're very small. They lay very few eggs and have very limited vigility. So here in Australia, this map shows where our known records are. And in Eastern Australia, these spiders are very much denizens of rainforest, complex notaphyll vine forest type habitats in upland areas. But they are found in other areas. They're found on Kangaroo Island, and a shout out to Jess for her extraordinary efforts in rediscovering one of the species which we thought might be extinct following those fires in the northwest of the island. But here in Eastern Australia, we have to extract them from rainforest habitats. These things are very small. They live in sort of the suspended leaf litter matrix in these complex forest systems. These suspended litter matrices are incidentally one of the first things to burn when fires move through these habitats, which of course should never burn. So how do we understand impacts on animals like this? So we're interested in using museum collection data. The data that we have here as systematic biologists and here in the state collection, and integrating that with some of the statistical modelling that Kasia talked about to try and get a handle on what these impacts might be on some of these really short-range endemic type taxa. There were 3 impact areas in our study, the Lamington Main Range and Balburren National Parks, shown here in yellow and blue. Lamington and Main Range being World Heritage Rainforest areas and Balburren being a subtropical upland rainforest area further north. I'll be focusing on the Main Range and Lamington areas for the rest of this talk. There's data behind this. There's a lot in these slides simply to show that the sort of data that went into this. On the left is a map showing known records from Southeast Queensland. The black dots are the old records, but the crosses and triangles are simply there to show that a lot of survey work has happened in the last 12 months following these fires. We sequenced all of the material, nearly all of the material that we collected to make sure that we had accurate identifications on every specimen that we collected so that could be fed into the analyses. And we use maximum entropy predictive habitat modelling using those collection data. So previously known collected specimens, but also all of the survey specimens that we did after the fires. And this is simply an example of one of those outputs. This is one of the species, Ostrachia nodosa, from upland habitats at Lamington National Park. The crosses are the actual collection records, and this is a sort of a MaxScent output showing a probability of occurrence shown there in grey shading in different areas. What you can do then with this sort of mapping is then map fire severity spatially on top of that to try and get a handle on what the impacts might be. Obviously, these small restricted spiders, difficult to collect. We really don't have a handle on everywhere that they might be, but this is one way of getting at that. And shown here are 2 of the species at Lamington. So on the left, Ostrachia nodosa is one from the more upland, the higher altitude areas, sort of above 750 metres. And the species on the right, Ostrachia dianae, lives in slightly lower altitude rainforests, mixed rainforests. And the coloured shading on top of the grey is the fire severity mapping available to us from the Department of Environment with a very sophisticated spatial mapping team that use satellite mapping to record the severity of these fires. And so this is simply a way of trying to understand what the overall impact might be on the species' distribution. And as you can see, the differences were quite significant between the species on the left, which was in an upland area, and the one on the right, which was from a more lowland area. In these fires at Lamington National Park in the World Heritage Area, the sort of lowland rainforests in particular were really severely burned by some of those blazes. Likewise, if we shift further west to the western end of the scenic rim, this is the Main Range National Park, also mostly rainforest and also World Heritage. And here are another 2 species, one with a range that's mostly centred in the north of the park and the other with a range in the lower end of the park. Again, for clarity, the grey distributions are the predicted distributions above a 50% probability. And again, we can map the fire severity onto these kinds of maps to understand those differential impacts on different species in different areas. Obviously, this is a really raw assessment. It's really a sort of a post-fire, sort of an immediate post-fire assessment of what some of those impacts might be on some of these poorly known species. But I'd also like to highlight on one of these in particular, species 1. This was a spider which was actually discovered new as a result of the fieldwork that was funded by the Commonwealth, supported by the state after those big fires. So far, it's only been found in the Mistake Mountains section, which is, for those of you who know the main range, north of Cunningham's Gap. The predictive mapping for that is on the left. The fire severity mapping on top of that is in the middle. But this really highlights this concept of cryptic extinction risk, which sort of comes across in the literature under various guises, but it's this concept of when we have these major threatening processes, these big events, and you know, and this applies to climate change going forward. There are taxa which are kind of off the radar, but are no less at risk. So in this case, it was a completely undiscovered species, which nonetheless was impacted, and while we now know about it, it is indicative of the sort of cryptic extinction risk that is there for these sorts of invertebrates after these sorts of events. But the exciting thing is, because of this work, we now know this animal, and we're naming it as new. So in summary, you know, understanding the impacts of these sorts of fires on these particular invertebrates, right? These regional endemic, dispersal limited, habitat restricted rainforest invertebrates requires a suite of things. It requires really good collection data, and that's where museums play a really important role. Habitat modelling itself, using programs like Maxent. Good spatial analysis information, for example, spatial data on fire extent, severity and impact, and of course good collaborations like all science. And in the future, really what's required is ongoing surveys to better understand how the spiders are coming back into these habitats, if at all, and also model testing. So actually taking these predictive maps and testing them to make sure that they are indeed indicative of where the spiders are being found in the landscape. Thanks very much.
That's excellent talk. Thanks, Mike. And yeah, these spiders are very close to my heart, so it's really great to learn a bit more. We've got a question in the chat if you'd like to have a look, or would you like me to read it out? Is that easier?
If you could read it out, please, yeah.
Okay, it's from Nick Porch. What were the most useful enviro layers?
That is a very good question. I should have come prepared for that. Look, it's moisture stress index was one of them. Annual precipitation in the lowest quarter. So there's actually I should have listed in this talk, but we've got a paper that's actually just come out, not by me, but by my co-author Mel Laidlaw, which lists this, which sets out this method, this standard method that we've applied post-fire. So Nick, I can point you in that direction.
And there's another quick question from Melinda. So we've got, if you could answer that quickly, or maybe answer in the text if it will take longer, which is, as always, Mike, an engaging, fantastic talk. I'm perhaps slightly biased. Why do you think Arcade adapted to aerial leaf litter, particularly in heath, which is fire adapted, e.g. along the WA south coast? Yeah,
good question. Look, I think, yeah, I'll need to talk to you about that afterwards, Mel. I guess, I think these spiders always survive in remnants, gullies, and so, you know, I guess it's a question of what has fire intensity been like in these habitats in the past, and are we seeing a shift to more sort of total destruction of habitat as opposed to the existence of mosaics under previous climate envelopes? Not sure. Thanks.
That's great. Thanks so much, Mike.